So today, we're going to do 1.2 notes for our comparing and scaling. We're going to be looking at mixing juices and comparing the ratios when we go to mix it. So it says every year the grade 7 students at Langston Hughes School go on an outdoor education camping trip. During the week-long trip, the students study nature and participate in recreational activities. Everyone pitches in to help with the cooking and cleaning up. This year, Arvin and Mariah were in charge of making orange juice for the campers. They planned to make the juice by mixing water and frozen orange juice concentrate to find the mix that would taste best. They decided to test some mixes. So, have you guys done like lemonade? A lemonade stand? Where you got to do the water and the lemonade mix? Well, that's what they're doing with the orange juice. So, we're going to look at a couple different ratios as to what they mix and how they mixed it to figure out which one's the best. So mix A, they mix 2 cups of their orange juice, the concentration, sometimes it's usually like a powder, the 3 cups of cold water. For B, these are all the different ratios. For B, 5 cups of concentrate, 9 cups of cold water. Mix C, 1 cup of concentrate, 2 cups of cold water. And for mix D, 3 cups of concentrate and 5 cups of cold water. So on this first page, that's what we're going to be looking at. I know it's not written on the board, but you guys have on your sheets, it says Part A, which mix will make juice that is most orangey? Explain your reasoning. What mix would be the most orangey? How do you think we would start doing this as well? The ratio of what? Orange, the mix concentrated to the water. Okay, exactly. So we want to start by figuring out how many cups is used total for each mixture. So for mix A, how many cups total are we just going to use in general, Blake? 5. We're going to have 5 cups. Oh, if I can reach this. Mix B, what are we going to have? 14? 3, 8. Oops, there we go. There's my funky 8. Okay, so now that we know that, let's find the ratios, the percentages for each mixture of concentrate and water. So to figure out the percentage of mixture to the total, how would we do that for mixture A? How do we find the concentrate to the total? Well, we know the total is what? For mix A. How many total cups do we have, Blake?
5.
Yep, we know we have 5. Thank you. So how many, I'm going to call it just orangey for the concentrate. How many cups do that, Lily?
2.
2, yeah. So if we were to figure out that percentage, what would it be? 2 divided by 5? 2 over 5? If we were to get that as a decimal, it'd be 0.4. And then we can move that 2 places to the right to get our percentage of 40, right? So this is 40. Now let's do the same for all of it, for the mixtures and for the water. So for water, for that same mixture A, how would we find the percentage? Robert?
5 over 14. Right?
Let's do mixture A still for the water. How would we do the water one?
Alright.
That's right for the next one.
So don't you have to add those up to find your bottom number for the
Yeah, so what's our bottom number?
5.
5. Add 3 on top. So when we want a percentage of that, what would we get? You wouldn't do 5 divided by 3. You would do it the other way. 0.6, so that's 60%. So we have to do this for all of them to find the oranginess. So let's go through and do the oranginess ones. Mix B, what's our total? Isabel?
0.3 total 14.
And what's in our numerator then if we're finding the mixed orange concentrate? 5. So as a percentage, what would that be written as?
0.357128571.
Okay, so let's round it to the 100th. 3.
300. Point 366.
We can round that to 0.36, couldn't we?
Okay.
Yeah. So when I do that, what's the percentage? 0.36. If we want to make that a percentage, how would we do that? Move our decimal. This is what we have. 0.36. I want it as a percentage. I could simply move it 1, 2, put my percentage there. So it's 36%, right? Thank you. Good job. Okay, mix C. What's my total?
So you gotta do the water.
We're just going to go through it. Let's just go through and do the concentrates first. We'll come back to the waters. 3 is our total. So what would I put in my numerator? 1. So 1/3. So what is my percentage? Isabel. 0.3 repeating. So if I want that as a percentage, 33%. Exactly. Good job. One more, and then we can answer part A1. What's my total? 8. And then my numerator? 3. So percentage would be Blake? 38%. Yeah. Good job. So now that we know my percentages of concentrate, the oranginess, for part 1A, it says what mix will make juice that is the most orangey? Explain your reasoning. So we want the one that's the most oranginess. So now that we found our percentages, we could figure out which one's the most, can't we? Just by simply looking at our percentages to see which one's the largest percentage. And which one is? Mix A. So I'll write it down here, since I don't have this question on my board. Mix A would be, and we can explain that because mix A is 2/5, which is 40%, which is the largest percentage. 40% for our concentrate. 60% is our water for that one, which is the largest percentage. Everyone see how we got that? Yeah? Aiden? They're the closest, the fractions are the closest together? Oh, okay. Yeah, you could do that too. You could do that. This way might be just simpler to compare these ones and just see which one's the largest instead of comparing each one from one another. But that could work. What about for part A2? Which mix of juice is the least orangiest? So, what are we looking for here now? What are we looking for? The lowest percentage of oranginess. Well, what would that be? Can I randomly call on someone? Mason, do you have it? What's our least orangiest? Mix C, exactly. So for 2A, mix C is the least orangiest. Thank you. And we know that because it is 33%, which is the smallest percentage. Okay. Let me scroll this up a little so you in the back can see it. Can you see that in the back now? Okay. On the next page, for part B, it says Isabel and Doug used the fractions to express their reasoning. Isabel said 5/9 of mix is concentrated. And Doug says 5/14. 5/14 of mix B is concentrated. So we're both looking at mix B. And we're both looking at the concentration, right? Can I go on to the next page? Are we done with this? So we're both looking at, ooh, it's very large.
Damn. Oh, sorry.
Which group is the most oranges? Okay, here we are. So, do you agree with them? Right here, it's written right here. It's really large. I don't know why it's written that big, but we can see it on our page. Do you agree that 5/9 of mix B is concentrate? Or Doug, 5/14 of mix B? Work with your shoulder partners for about 2 minutes to determine who you agree with, whether you agree with Isabel or whether you agree with Doug, and why you do. All right, I'll give you about 2 minutes. So Doug or Isabel, who do we agree with? Oh, Ona.
I said I agree with Doug because altogether there are 14 cups.
Okay.
And 5 of those cups are made from the orange concentrate. So that's why Doug's fraction 5/14 matches.
Exactly. Do you know why Isabel's is wrong?
Yeah, because Isabel's is more, well, I first thought it simplified, but I thought it can't be simplified.
Right.
So then there altogether are not 9 cups, so just wouldn't make sense.
Yeah, so if we look at when we do like ratios with this stuff, you guys have questions? Okay, hold on 1 minute then. When we do ratios, we want to compare a part of the object to the whole object. If you look at Isabel, she said 5/9. Well, 5 is the concentrate for the 5 cups of concentrate for mixed B. That's correct. But then she did over 9, which is the 9 cups of cold water. Well, that's not comparing. Those are 2 different parts. She's comparing a part to a part. We don't want to do that. We want to compare a part to a whole. So that's why, Eleanor, you're correct. Doug, we agree with Doug because he did part to a whole. His denominator of 14 is the total amount of cups that mix B uses, and his 5 in the numerator is the concentration, the 5 cups of concentration that they use for mix B. So for 2, Max thinks that mix A and mix C are the same. Max says they are both the most orangiest since the difference between the number of cups of water and the number of cups of concentrate is 1. Is Max thinking correct? And explain. I'll let you work again with your shoulder partners or table partners to determine whether Max is correct or not and why. Why is his statement they are both the most orangiest since the difference between the number of cups of water and the number of cups of concentrate is 1? I'll give you about 2-3 minutes. Sounds good? Let's come back together. Let's come back in. All right, thank you. 2. Is Max wrong or not? Let's get a new hand. I appreciate you volunteering. Ashley. Because 40 is bigger? Okay, that's a good way to look at it. You're right. Max is not correct. Does anyone else have a theory too? There's a couple different ones we can look at. Robert?
I said no, but I can't split half and get the same.
Okay. That's true. We can't do that. That's true. Anyone else have a theory? Divide by different numbers. Okay, that's also, we can work with that, Ava. All right, so why don't we look at the ratios? It says mix A and mix C. We're only looking at the oranginess. So for mix A, let's look at the ratio from oranginess to water for mix A. Remember, we can write it as a ratio as like a fraction, like this, or with our colon. What if I say for mix A, This writing is so big. I'll write it up here. 2 to 3. How do I get that? How did I get 2 to 3 when I looked at mix A? Lily? Yep.
So it had 2 cups of the concentrate,
Mm-hmm.
3 cups of the
2 cups of the concentrate and 3 cups of the water. So I compared my two ratios because that's going to determine how strong and how orangey it really is, depending on how much water. If I add a lot of water, it's going to get diluted. If I don't, it might be really strong and really like citrusy. So that's going to be what I'm deciding it between. How much water they use compared to how much concentrate they use for those two mixes. So let's look at mix C. What's the ratio that they use for that one? Anyone else? Look at your front page, the mixture of C. I'm going to randomly pick someone. Anthony Marisi. 1 to 2. Okay. Do those equal one another? No, they don't. They do not equal one another. Therefore, Max thinking that mix A and mix C are the same. Max says they are both most orangey, since the difference between the number of cups of water and the number of cups of concentrate is 1. Well, the difference between them is not 1. So he's already wrong there. Is Max correct? He's already wrong. They're not a difference of 1, and they're not the same. They do not equal each other. So that is why Max is wrong. I'm going to write over here. Max is wrong. And so these little ratios that I wrote right here is why. This is our number 2. I wrote it up here since I don't have much writing down there. Okay. Let's go on to part C. Okay, part C. Assume that each camper will get a half a cup of juice. Answer question 1 and 2 below for each of the 4 recipes. Show your work or explain your reasoning. Doesn't have it here, but we need 120 cups total. This will help us to answer these questions. So, for 1, how many batches of recipes are needed to make juice for 240 campers? 240 campers. How would we find this? Blake. Well, we can figure out how many cups are in our batch, can't we? How many cups do we say our grand totals were on our front page? We can look at mix A, mix B, mix C, mix D. We added them all up, and I put it on the left-hand side. Let me see if I can go back real quick. Didn't we add up our totals here? These are the total cups that we use. So, if we go back to this page, for part C, for 240 campers, and we know that we need a total of 120 cups, okay, well, here's 1A. This is for mix A, right? How do I find the amount of cups that I need? How can I do that based on knowing I need this many? How many do I have? Elena?
I added all the numbers up and I got 30, and then I took 120 cups and I divided by 30, and then I got 4. So I'm not sure.
You're on the right track, but you're adding up the totals of mix A, B, C, and D. We want to look at just mix A.
Oh.
So now that you know we're looking at just mix A, can you give us a new answer? All right. Thank you.
24.
Thank you. So she took the total that we need, 120, right? I wrote that up here. And she took it from the total cups that we have used in mix A, which we wrote on the left-hand side, right? We have 2 cups of concentrate and 3 cups of water. Well, that gives us a total of 5 cups. So if I divide 5, that would give me 24. So if we go on to mix B, I'm just going to write B here. What would I do, and what would my total cups be? Robert? 120 divided by 14, because that's the total cups that we use on the first page. And when I do that, what do I get?
8.5714.
Okay, so can you round that to a whole number, please?
8.50.
A whole number, not a decimal. You can round it up, can't you? Because it's 8.5.
No, 8.9. Sorry.
What is it? 8.57. So if I have 8.57 and I want a whole number, what do I do to round this up or down? I look at this number, right? If it's greater than 5, I can round it up. So this is roughly 9. Thank you. Next C. Lily?
Okay, so your 120 divided by 3, which is 40 cups.
120 divided by 3, because that's the total cups we had on our front page, and that gives us 40 cups. Can I move this up a little? There we go. Now you can see it. And D. Ashley. 120 divided by 8 is 15. Exactly. So when it says how many batches of each recipe would we need, well, we would need 24 batches for mix A. We would need roughly 9 for B, 40 for C, and 15 for D. Now for the second part, it says how much concentrate and how much water are needed to make juice for 240 campers. Why don't you work with your shoulder partners for like 2 minutes on figuring out mix A, B, and C, and D for the concentrate and water. A little hint for this one, you can use those new batches that we found, those new totals that we just found for each mix to help you find your new amounts. For question 2, mix A, we need to find the concentrate and water, how much is needed to make juice for 240 campers. Well, we already found on part C, question 1, how many batches we need for mix A, right? How many batches do we need? How many batches? I'm going to write it right here. We need 24, exactly. So for mix A, we need 24 batches. Well, we need to find how many cups of concentrate we would need and how many cups of water we would need. So can't we look at the total amount of cups that we originally used on our first page? Yes? Okay. So Stephanie, when we do that, what would you get for a concentrate? 120. Close. Okay. 40.
For the what? For
The concentrate of mix A.
mix A, I got 60.
60. Anyone else get something?
48.
48? Okay, how'd you get 48? Because 2 is the amount of cups that we use. Exactly. Thank you, Ava. So on that front page, when it says 2 cups of concentrate for mix A and 3 cups of water for mix A, we multiply that by the number of batches that we just found that we need. So when we multiply that, we get 48 for the concentrate. I'll put CON for concentrate. So now we do the same thing for our water. 24 times what? 3. And that gives us
72.
72. Then I'll just put H2O for our water. This should be down on your question 2 on the 3rd page. This is where we should be writing it. Okay, for B, now what? Ava? For B? Is that the number we found for B for the number of batches on our 2nd page? How many batches did we find for our 2nd page, Anthony? We found 9. On the bottom of our second page for mix B, we're looking at just mix B now. We found that we need a total of 9 batches. So we're going to be working with that number. And to find the concentrate, how many cups total we'll need for the concentrate, we're going to go back to our front page. Well, how many cups of concentrate did we use for mix B? Yeah, Lily, we used 5. So we're going to multiply that to get 45 for our concentrate. Does that make sense how we got that? Who said no? Robert? We got our 9 from our second page. If we go down to our second page, see how we got 9 over here? That's our total number. And now we're going to take the total cups that we found, that we were given on the front page, to multiply to get our new total cups. So we're going to do that for each one of them. So for our water, what is it for water? If we have 9, we know we have 9 batches still. Sal? Yeah, 9 times 9, because they told us that we need 9 cups of water. That's 81 for our H2O, our water. What about C? 40? Because you would multiply what? 40 times 1, exactly. And what about our water? Yeah, thank you, Brayden. So 40 times 2 will give us 80 for our H2O. What about D? Last one. Elena.
For concentrate, I got 45.
Okay, and how'd you get that?
I took 15 batches for what we did on the last.
We needed our 15 batches, and you multiplied it to what?
Multiplied it by 3 cups of concentrate.
3 cups of concentrate, and you said that gave you 45 for your new concentrate? Yep, exactly. And what about our water, our last one? We're going to use our 15 batches that we have, and what are we going to multiply that to? Rebecca, you want to try this one? 15 times 5 for our total water cups. And what did that give you? 75 for water. Exactly. Now part D. It says for each recipe, how much concentrate is needed to make 1 cup of juice? How much water is needed? This is exactly what we were doing with our percentages and fractions on that front page. So let's look at mix A. How much concentrate is needed? We want to take our total number of cups and figure out how much concentrate. Well, how much concentrate did they say we need for mix A, Robert? We need 2. And how many cups total did we work with? We worked with 5. Exactly. So for part D, mix A, our concentrate, we need 2/5 cup. Or if we want to simplify that down as a fraction like we did on our front page, it's 40.4 or 40%. Remember doing that on our front page? So what about the water for that? If we need water for mix A, what is it? Water is 3 because that's the total cups that we used, and the total cups of water we used. And then our 5 is the total cups that we just worked with in mix A in general. So we could write it as 3/5 cup, or we could write it as 0.6 cups, or 60%. So we go on for B, C, and D. For B, what is B? For our concentrate. What, Lily? 36.36. How did you get that?
As I looked at the front page for the concentrate, we did 5/14.
5/14, exactly. So then for our water, we had 9/14. What about C? Concentrate, what do we have? What's our ratio that we use for our concentrate for part C? Mix C. Lily? 33%, 0.3, or 33%, or we could write it as 1/3. You can write it as any of these. The fraction, the percentage, the decimal, any of them. I'm just doing all three so you can see your options. What? I didn't write the percentage right here.
No, for the
Water.
for the water, yeah.
I just didn't write it out. We have 0.64, or it could be 64%.
All right.
For our water down here, we need 2 cups of water, and it's total 2/3, because we need total 3, which is 0.6, or 60%. And lastly, our D. Real quick, let's get our D in. What do we need for D? How many cups of concentrate? Lily? 38%. How did you get that? 3/8. And for water, it was 5/8, which was 0.62, or 62%. So using these notes, go through your book, and we will have homework, page 22, questions 10, 11, and 12. Page 22, I'm going to write it up here for you. Page 22, numbers 10 through 12. And have this done for tomorrow, because we're going to get started on a new section tomorrow. Use these notes that we just went through to help you answer those 3 questions.